Okay, guys, so standard 26, it's similar to 25 as far as you're thinking about the unit circle goes. But unlike inverses, we don't have to think about which part of the circle it's in. We get to use the whole circle. So right here where it says 0 to 2 pi, that's telling you you can work all the way around the circle. Okay, so which quadrant, all of that, just get that out of your brain. Think about the whole circle. Do you notice that this one is less than or equal to and this one's just less than? What does that mean? Right, so like the zeros included, 2 pi would not be an answer that you can include. It goes right up to it, but all of those values should be covered by 0. Okay? All right, so let's look at what these types of problems are going to be like. So the first one here, cosine of x equals 1/2. I'm just asking you to tell me from 0 to 2 pi, where is cosine equal to 1/2? So where does that happen? Pi over 3. And is there another place? Good, 5 pi over 3. Okay? You're going to have multiple answers for these. So again, different than the inverses that we were looking at, where you only had one answer. So it's the 2 quadrants where cosine's positive, and then you tell me that value. Let's do b together. So sine of x equals negative root 2 over 2. So just think all the way around the circle.
5 pi over 4, 7 pi over 4.
Perfect. And there's no like special notation. Just tell me x is 5 pi over 4, 7 pi over 4. Making sense? Okay. I want you guys to try C and D. Now D, it says 1 over root 3. How else might I write that that's maybe more familiar? Root 3 over 3. You guys see how that's the same? Okay. All right, so try those two. Check with your neighbors, see if you guys agree on the answer. Talk to someone around you, see if you agree. Do you remember your tangent shortcuts on the last one? Agree? If you chatted, some of you are sitting silently today. Is it too early to speak? Is that yes?
For C, pi over 2 and 3 pi over 2.
Perfect. C is pi over 2 and 3 pi over 2.
For D, I got pi over 6 and 7 pi over 6.
Yes. Again, guys, if you know your circle really well and know those sine and cosine values, this is pretty easy. If you don't know those, this is hard, okay? So at some point, you must learn those values on your circle if you haven't already. A lot of you have, but yes. Okay, so let's think about, remember the shortcuts I've talked about with tangent and cotangent? Let's just go over those again and I'll show you like what your brain should think about. So tangent of anything over 6, meaning pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. You have to figure out Some of them are positive, some of them are negative, but that's always root 3 over 3. And that's going to be the same as a cotangent of any of the over 3s. Okay. Tangent of the over 4s is always 1, and that's the same for cotangent of the over 4s. Okay. Tangent of the over 3s, root 3, and that's the same as cotangent of the over 6s. Okay, so that last problem said tangent of x equals, was it positive root 3 over 3? 1 over root 3, which is the same as root 3 over 3, right? Okay, so I look at this and I go, okay, root 3 over 3, that's here. Okay, so I know it's going to be, since it was tangent, I know it's something over 6. Then you just have to think about, all right, it's positive, so is that pi over 6, 5 pi over 6, 7 pi over 6, or 11 pi over 6? Like, 2 of those are positive and 2 of those are negative, right? So first and third quadrant, so pi over 6 and 7 pi over 6. Does that make sense how to work backwards? Okay. So if it said like tangent of x equals negative 1, you go, okay, negative 1. Tangent, so it's got to be some over 4s. It's the 2 where it's negative, so it's the second over 4. Is that helpful? Okay. All right, so are we okay with A through D? All right, the next section here. Again, our directions are 0 to 2 pi. At some point, those directions are going to change, but for right now, still all the way around the circle. Let's look at what I've given you here. So on the left here, I've got 2x plus 1 equals 0. That looks like an algebra 1 equation, right? Okay, do we know how to solve that? Yes. All right, what do I do? Subtract the 1. Perfect. Then what? Divide by the 2, I get x equals negative 1/2, right? Okay. Look at b that is next to it over here. Now I put a sign of x in there, but the process of how you solve it is the same as what you did on the left. So first I would subtract the 1. Then I would divide by 2. So I now have sign of x equals negative 1/2. So you have one more step to do. You have to think on your circle, where does sign of x equal negative 1/2? So what would you tell me? Close your eyes, see the circle, okay? It's something over 6, because this is the y value, so I need the short leg, okay? So it's the over 6's, but which 2 over 6's is it?
5 or 6.
And?
5 or
Yes. Third and fourth quadrant, right? Sign is y, it's the 2 at the bottom. So 7 pi over 6, 11 pi over 6. Okay, does that make sense? All right, I want you to try 2, 3, and apparently another number 3. I don't know why that's 3. Yes?
I say like instead of 11 pi over 6, like negative pi over 6.
Okay, so those are coterminal, but is 11 pi over 6 in 0 to 2, or I'm sorry, is negative pi over 6? Does that make sense? And I could do weird things and like change the window on you and say, only give me answers from negative 4 pi to negative 2 pi. I'm not going to do like that window, but you just want to make sure the answer you give is in there. Yep. All right, so on these, again, do the A first, followed by the B, because it's going to be the same process. through them. Let's see how your factoring went. So for 2a, did you guys know what to do on the left?
No.
Okay. It's only two terms, so you're not factoring a trinomial. So you have to look for a GCF. Okay? X, exactly. Take out an X. Okay? Now guys, from here, do you remember how to solve? Okay. Yesterday, a bunch of people told me this too. They're like, I don't remember this from Algebra 2. This is kind of crucial, solving by factoring. It's called the zero product property. You can set each factor equal to 0 then to solve. Okay, so I have x equals 0 and x minus 1 equals 0. So then over here, those would be my two answers.
So I think our issue was, I think, like, I did it like that later on with like another two things, and I did that, but I had like other numbers like full like x minus one, like another one like that, like x.
So it's not a trinomial, meaning three terms?
No, like it wasn't like, it was like, with number 3 I had 2x minus 1 and x plus 1, and there was
Yeah.
like numbers involved, like it was like.
Okay, so this, see how this has three terms?
I know, but like that one though, like it was just like the factor was 1x and 2x.
It doesn't have three terms, so you can't factor it the same way. So you will not get like you did down here. You won't get something like that.
I know, but like, that's why I got confused. I realized just pull that out.
So if there's two terms, you look for a GCF, greatest common factor. That's the fact. That is the factoring. There's no more factoring. You just set the two factors.
I just does set just the x.
You want to write it as like x plus 0. Yes. All right, so then for B, we have to do the same thing, but with our cosines. So what can I factor out of this one? Cosine of x, right? Okay. Cosine x minus 1 equals 0. Everybody understands why the 1 has to still be there? Okay. Yeah, otherwise you multiply it out and it wouldn't be what you started with. Okay, then set the two factors equal to 0. So this one I could add the 1. Okay, so I have these two things that I'm looking at now. So where does cosine equal 0? Where does that happen? Pi over 2, where else?
3 pi over 2.
Good, so those are two of my answers. And then, where does cosine equal 1?
0.
Okay, 0 I like. At pi, what is it? Is it 1?
2 is what I said. 2
it's-
pi.
Okay, 2 pi, yes. Is 2 pi included as an answer choice up here? No, okay. Ooh, moving. Okay, so 0 is actually the only answer. Did anybody say pi? Okay, so it'd be -1 over there. Okay. All right. So do we feel kind of okay with number 2? Getting there? Okay. All right. Number 3, not a factoring problem. What'd you guys do? Okay. So you added the 3, divided by 4. Yes, I know where you're going. And then we can square root both sides, right? What do we need to remember when we take the square root? Yes. What else? Plus or minus. So this is really plus or minus root 3 over 2. Okay. Algebraic process, we okay with? Let's do this with signs. So same idea. You're going to add the 3. You're going to divide by 4. Square root. I have sine of x equals plus or minus root 3 over 2. Okay, plus or minus, what does that tell me as far as how many answers you're going to end up with? 4, because it's going to be all the positive answers and the negative answers. So that's 1 from each quadrant. So what's it going to be? All of the over what? Yes, all of the over 3. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Does that make sense? We see it?
Yes.
Okay, we understand why there's 4 answers? Okay, remembering that plus or minus is pretty important. Let me move it up a little bit, sorry. The other number 3, second 3. Okay, this is factoring again. All right, it's a trinomial. I don't care how you factor as long as you can factor correctly. I would like you to get to the point where you don't have to draw like a box and a circle and all of that every time, but it's fine if you still need it as long as you factor correctly. I look at it and see the only way to get 2x squared is 2x times x. The only way to get a -1 is a +1 and a -1, so I just need to figure out which sign goes where. Looks like I need that so that I get a +1x if I were to multiply it out. That's essentially guessing and checking. You're just thinking about the possible factors for the first term and the last term and checking to see if it multiplies to give you that middle term. Okay? So then I set each factor equal to 0. I get x equals 1/2 and x equals -1, right? So same process then with our cosines. And guys, you can always think of this with just x's first and then put the cosine back in if you need to. So I'm going to have 2 cosine of x minus 1 times cosine of x plus 1. Okay, set those factors equal to 0. So I'm looking at cosine of x equals 1/2 and cosine of x equals -1. Are we doing okay getting to that point? Okay. All right, once around your circle, where does cosine equal +1/2? Pi over 3. So first quadrant, where else is cosine positive? What other quadrant? Fourth quadrant. So I got pi over 3, and then what's the fourth quadrant one going to be? Good. Yeah, 3. Okay. And then where does cosine equal -1? Just at pi, right? Only one spot? Okay. Questions on the first page here? Okay. All right, turn the page when you're ready. All right, let's skip 1 and 2. You guys try 3 and 4 for me, okay? Just do these 2. Second. Check with your neighbor, see if you agree. How we doing, guys? You got them? So does the team matter? All right, guys, let's go through these. We're running out of time here today. Okay, so 3, you could have factored out the 2 if you wanted to and set them equal, or you could have subtracted the 2 and divided by 2. Either way, you're going to get to this point where cosine of x equals -1. So where does cosine equal -1? Pi. Good. That's it. Okay? All right, number 4 is a factoring problem. Guys, if you're weak at factoring, please come and see me in Warhawk Time. I will give you more practice on factoring. It is a skill that also does not go away. Okay? You will see factoring all through calculus. Like, it's a thing you got to be able to do. When there's not a leading coefficient, so this is basically x squared minus 2x plus 1, you need to be able to just look at that and go, all right, x minus 1, x minus 1. Okay, so this is going to be cosine of x minus 1, cosine of x minus 1. Do you think I really need to set both of them equal to 0?
I just have a question. If I was to write x minus 1, am I required to then go put that cosine of x minus 1, cosine x minus 1? Or can I just leave it?
Okay, how are you going to answer the trig part of it if you don't have the cosine?
Because I'll write the answer part with the cosine part. I just
That, like, you're still going to write, like, cosine of x equals 1?
yeah,
Yeah, at some point you have to get the cosine factor.
but I don't need to like.
It's not a proof where I'm going to be checking, like, is every step equivalent to the previous step.
Okay.
So go through your factoring however you need to go through it, but you have to at some point get back to that. Okay?
Okay.
Don't just stop and tell me x equals 1 and then think you're done with the problem.
Yeah, but if I just instead of doing that, wrote cosine equals 1. And that
Cosine of x.
Cosine of x, yeah.
All right, guys, so what's our answer for this one?
0.
Just 0, right? Okay? All right. New directions. Find all solutions. Okay. We are no longer talking once around the unit circle. Do you guys recognize that it just repeats? you could go around and around, or like your graph just goes forever and ever and ever. Do you remember when we did the domain and the asymptotes? We would say like pi plus or minus pi k, because the k allowed us to keep going forever and ever. That's similar to what we're going to do here. So we're going to start the same way we have been. Sine of x equals 1/2. Where does that happen? What are my two answers that you tell me if we were just going once around the circle? Pi over 6 and 5 pi over 6, okay? Now, how far is it all the way around the circle? 2 pi. So I'm going to say plus or minus 2 pi k. The k is telling me that I can go around 1 time, 2 times, 3 times, 78 times. Like, it's all of them, okay? So all you do is answer it the normal way, and then at the end say plus or minus 2 pi k. So if the directions say all solutions, okay? All right, one more, guys. So what do I need to do to solve 6? Square root, okay. So I'm going to get tangent of x equals plus or minus root 3. All right, plus or minus. So I got a lot of answers here, right? It's all of the over what's? Over 3's, good. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And then what do I have to do to each one of those? The 2 pi k thing, right? So plus or minus 2 pi k. Okay, some of you are probably looking at that going, gosh, that's a lot to write. It is. Do you see another way I could do this and maybe not write all of them? I start with pi over 3. What if I add pi k to it? Because what's pi over 3 plus pi? I'm asking a lot this morning, I know. You guys are like, What is pi over 3 plus pi? 4 pi over 3. So that's going to take care of that one, right? And then I say 2 pi over 3 plus or minus pi k. Well, what's 2 pi over 3 plus pi? 5 pi over 3. So it accounts for that one. So that's another way you could write it. If that is confusing to you, just write them all. It's fine, okay? But if you're like, oh, that's shorter, I get what's happening there, then do it that way. That's fine. I would take either set of answers. Okay? All right. Homework, guys. For standard 26, turn the page. It's the next page in your packet there. Let's just do evens. All right.